In this exercise problem from exercise 9.3, question number 4, we are given a circle with a chord BC, and that chord BC subtends some angle, angle BAC and angle BDC at points A and D on the major arc BC of the circle. Okay. Now we are given that the angle ABC is 69 degrees. So angle ABC is this angle over here. So ABC. So that's that angle between the two black lines. So let's mark that. And that angle is given to be equal to, so that entire angle is 69 degrees. And we are also given that the angle ACB is 31 degrees. So angle ACB is this angle between the black lines here. That is given to be equal to 31 degrees. And we are asked to find the angle BDC, which is the angle between these blue lines here. Okay, so that is the angle that we are supposed to find. So we'll put that as a question mark. Okay, so to find angle BDC, it will be sufficient if we find angle BAC. So if we are able to find angle BAC, then BDC is the same as the angle BAC, because BAC and BDC are both angles subtended by the chord at two different points on the circle, and the angle subtended by the chord at two different points on the circle on the same side of the chord are equal. Okay, that's a theorem that we have seen earlier. So based on that theorem, so angle BAC is equal to angle BDC. So once we are able to calculate angle BAC, then BDC will be the same as the angle BAC. Okay, so now let's write that down. So we have here angle BDC equals angle BAC, because they are both angles which are in the same segment of the circle. So BAC is subtended by this BC, and BDC is also subtended by the same chord BC, or by the arc BC. Okay, so they are angles in the same segment of the circle, and therefore they are equal. Okay, now we can go ahead and compute angle BAC by considering the triangle ABC. So in triangle ABC, the sum of the three angles should be equal to 180 degrees. That is the angle sum rule for the triangle. And we know angle ABC is 69 degrees and angle ACB is 31 degrees. So therefore, we should be able to now compute what is the value for angle BAC. So therefore, we now have from the sum property of the angles in a triangle that the sum of the three angles in the triangle ABC should be 180 degrees. We know the two angles, so we can calculate the third angle, which works out to be 80 degrees. Okay, because angle BAC plus 69 plus 31 should be 180, and that's 100 degrees. And therefore, we get angle BAC to be equal to 80 degrees. So that means we have this angle over here as 80 degrees. And since we now know angle BAC, we can then get the value of the angle BDC, which is the same as the angle BAC. So therefore, we now have angle BDC, which is the same as the angle BAC. So that's also equal to 80 degrees. So we have obtained the angle BDC, which is the same as angle BAC, because BAC and BDC are both angles lying in the same segment of the circle. Okay, the segment is the BC, so it is the angle BAC is the angle subtended by BC on the side of the circle, on the major arc of the circle. Similarly, the angle BDC is also the angle subtended by the chord BC on the major arc of the circle, and therefore these two angles are equal, which is from one of the theorems in the chapter of circles. Okay, so we have now obtained the value of angle BDC as 80 degrees, which is what we had to find out in this problem. Okay, in this next exercise problem, which is question number 5 from exercise 9.3, we are given a circle with a chord BC, and it is stated that A, B, C, and D are 4 points on the circle, and we have a chord BC, and then we have two segments AC and BD, that is the line segment AC and the line BD. intersecting each other at E at this point over here, such that the angle BEC is 130 degrees. So that means we are given that this angle over here is 130 degrees, and also we are given that the angle ECD is 20 degrees. So angle ECD, which is this angle over here, the angle between the black and the pink lines, that is given to be equal to 20 degrees. So from this we are asked to find what is the angle BAC, so which is angle BAC, the angle over here between these two black lines, between BA and AC. So that's the angle BAC, which we are supposed to calculate. Okay, again, to solve this, what we first notice is that the angle BAC and the angle BDC are both angles lying in the same segment of the circle. So therefore the angle BAC and BDC are equal angles. Okay, so we will use that idea, and we have information enough to calculate the angle BDC, which is this angle here. And once we calculate angle BDC, we can obtain BAC, because BAC is the same as the angle BDC. So that's our first observation. So what we notice is that angle BAC is equal to angle BDC. Why? It's because they are angles in the same segment of the circle. And they are equal, right? This is our theorem. Okay, are equal. Okay, so that's our first observation. And then to solve this, we will have to apply some of the ideas that we have developed or learned in our earlier chapters, in the chapter of lines and angles. Okay, so we are given here that the angle BEC is 130 degrees. So that means the angle AED, which is this angle over here, that should also be 130 degrees. So the angle on this side here should also be 130 degrees, because these are vertically opposite angles. So if this is 130, this should also be 130. So 130 plus 130 should be 260. Okay, so angle AED is equal to angle BEC, because they are vertically opposite angles. And vertically opposite angles are equal, which is what we have learned from our chapter on lines and angles. Okay, so once we know that these two are equal, then we know that now what will be the other two angles here, which is the angle AEB and the angle DEC. So the total angle here should be 360 degrees. Out of that, 130 and 130 for the angle BEC and angle AED, that makes it 260 degrees. So what is left is 100 degrees, right? So we will have angle AEB plus angle DEC. Okay, these should be equal to 360 degrees minus the sum of the angles BEC, angle BEC plus angle AED. Right, so we have this to be 360 degrees minus BEC, we know is 130, plus AED is also 130, because they are vertically opposite angles. So 360 minus 260 will give us 100 degrees. Okay, so angle AEB plus angle DEC, which is this angle over here between the black and the pink line, and the vertical opposite angle here, these two are adding together to be 100 degrees. So let me mark those two angles with a different color. So we have this angle over here plus this angle over here, and these add up to be 100 degrees. And also, because they are vertically opposite angles, they should also be equal. So also, let me write here, also angle AEB is equal to angle DEC because they are vertically opposite angles, okay, and they are equal angles. So now from these two relationships, that is angle AEB plus DEC is 100 degrees, which is given, we've represented that as equation 1. And we also have that angle AEB and angle DEC are also equal, which we denote as equation 2. From these two equations, we can say that angle AEB and DEC are both equal to 50 degrees because they are both equal and their sum should be 100 degrees. So each of them should be 50 degrees. So we now have in the figure this angle here BEC is 130 degrees and AED is also 130 degrees. So this is also 130 degrees, and we have angle AED as 50 degrees and also this as 50 degrees. Okay, so which is the angle DEC, that's also 50 degrees. Okay, so now we have enough information to calculate the angle BDC, which is this angle here, by looking at the triangle DEC. So we will observe the triangle DEC, which is this triangle over here. We have two of its angles and the third angle is the missing part. So now we will look at this triangle DEC and use the sum angle property of the triangle. So in triangle DEC, the sum of the angles should be 180 degrees. So we can now find the angle BDC. So now from the triangle DEC, we have the sum of its three angles to be 180 degrees, which is the angle BDC plus the angle DEC plus the angle DCE should add up to 180 degrees. And we know that DEC is 50 degrees and DCE is 20 degrees. So we get angle BDC to be 180 minus the 70 degrees to be 110 degrees. So we have obtained the angle BDC here as 110 degrees. And since we have established earlier that the angle BAC is the same as the angle BDC, because they are both angles in the same segment of the circle and therefore they should be equal. So therefore we now have angle BAC to be also equal to 110 degrees, because angle BAC is the same as the angle BDC, and we have found that angle BDC is 110 degrees, and therefore our angle BAC is also 110 degrees.